Hey, what's up everybody? It is Mr. Boylan, and today, what in the heck are we gonna do in this video? We are going to differentiate, or tell the difference, between physical and chemical changes, physical and chemical properties, and intensive and extensive properties. As always, let's take a quick moment to break it down. There is a lot there. Numero uno. Let's identify a property or change as either physical or chemical. 2. Explain why a property or change is physical or chemical in terms of bonds. Number 3, define intensive and extensive properties. And then finally, identify a property as either intensive or extensive. Hold on to your hat, it's gonna be a good one. Alright, so to start things off, we're gonna take a look at some physical properties. And physical properties are characteristics that can be observed or measured without changing the identity of the substance. Now, some great examples of physical properties include color, melting point, malleability, ductility, density, solubility, mass, volume, and viscosity. But remember, the important thing to take away is that you can observe these things without changing the identity of the substance. The paper is blue. Blue. Now let's talk about physical changes. When a physical change takes place, chemical bonds are not broken in the reactant and no new chemical bonds are formed in the product. The identity of the material does not change. It's still paper. It might be in two different pieces and it might be a little crumpled up, but it's still paper. Physical change. Now, a couple great examples of physical changes include changes of state, or phase changes. I like to think of water. Right now we're swimming in molecular view water. We've reached the surface and it's beginning to evaporate, going from the liquid to the gas phase. But notice, it's still water. The identity does not change. As the water evaporates, notice how the hydrogen, or the white spheres, and the oxygen, the red one, stay bonded together. Another great example of a physical change are changes in form. Now, let's talk about chemical properties. A chemical property relates to a substance's ability to undergo changes that transform it into a different substance. So, a chemical property includes reactivity, flammability, toxicity, pH, ability to tarnish, ferment, or oxidize. In order to observe a chemical property, the identity of the material must undergo a change. Flammability. This is why I love being a chemistry teacher. Fire. Now, when a chemical change takes place, chemical bonds within compounds are broken in the reactants and new chemical bonds are formed in the products. The identity of the material does change. So a great example of a chemical change is the combustion of methane, CH4, in oxygen. The carbon-hydrogen bonds are broken, as is the bond between oxygen in the oxygen molecules. The products, carbon dioxide and water, are formed upon the creation of new bonds. Boom, chemical change. Now there are a few things to look for in the lab to let you know you've got a chemical change. First, energy change, heat and light. Boom! Yes! The production of a gas. Be careful with this one. We're not talking about a phase change going from a liquid to the gas or solid to the gas. We're talking about the production of a new gas. So check out this thriller of a video as we add metal to acid. We get the intense formation of a lot of gas. Bubbles! The formation of a precipitate, which is a really fancy term for the formation of a solid. Now this one's sometimes difficult to identify in the lab for students, but we're starting with two aqueous solutions that when we mix them together forms that solid. The solid, however, doesn't always look so solid as you look at your screen here. A lot of times it's sort of this milky, squishy looking stuff. However, as time passes, that precipitate will settle to the bottom. Another great indication of chemical change is formation of an odor. And finally, color changes are also really great ways to identify that you've got a chemical change as opposed to a physical change. Okay, last things to talk about in this video, Intensive and extensive properties. An extensive property depends on the amount of matter present. It matters how much matter. Three great examples of extensive properties are mass, volume, and length. Now, as an example, I'm going to use this giant beaker of water. Boom! It has a volume. Let's add some more. I've added more water. The volume has changed. Extensive property. It will change depending on the amount of matter that you have. The mass of this sucker has also increased. I can barely hold it up. Intensive properties, on the other hand, do not depend on the amount of matter present. Here we have things like color, density, malleability, ductility, luster, odor, melting point, boiling point, conductivity. Let's come back to my beaker of water. The color, or lack of color, the water is colorless at this given volume. But let me change the amount of matter I have. I now have far less amount of water. The color has stayed the same. Intensive property stays the same no matter how much of that material you have. Okay, and that does it for this video. As always, check out the references beneath the video to find some of the links to those great videos that I showed you in this one.